back to the Future Print Virtual Summit for our next section, our next session in the Industrial Print Day. Unlocking the potential of new markets with the software in your digital press is the title of this session. And it's delivered by a company called Global Graphics Software, who developed the core components used to drive digital presses from the likes of HP, Durst, Roland, Canon, Miyakoshi, and many more. These include, product-wise, the Harlequin RIP, ScreenPro, PrintFlat, and Mako. This year, Global Graphics won the coveted Queen's Award for Enterprise, recognising innovation in the development of ScreenPro with PrintFlat, which I think we'll be touching on later on, gentlemen. So I'm going to introduce them now. So Martin Bailey is the CTO of Global Graphics Software. Welcome, Martin. Hi. Jeremy Spencer is the VP of Business Development for Global Graphics Software, and Ian Bolton is the Product Manager Direct for Global Graphics Software. So thanks for joining us, gentlemen. We're going to be unlocking, which is, I think, clearly a critical component of any printing process, not least one that is attempting to enter a new market. So I think this is an interesting and perhaps often overlooked area. You guys have been developing software for printing for more than 30 years now, so you're a real early innovator or pioneer in the field. Martin, I believe you've seen the business change and develop over that time. So yeah, if you could explain a little, that'd be great.
Yeah, I've actually been with Global Graphics Software and its precursors for very nearly 30 years now. When I joined, we focused primarily on offset print, but the world has changed a lot since then. And in the last couple of decades, we've been very much focusing on digital print in general and inkjet in particular. So the market has changed around us, and we have adapted to make sure that we're in the place that our customers need us to be when they finally realize that they need us to be there. And our entire focus is on software for print. If it's not for print, then we're not doing it. And that does tend to make us work very hard to stay ahead of the game. And it's been fascinating working in that place, working with a lot of different vendors in different markets, and seeing the adoption of inkjet printing spreading across the whole of print, obviously starting in transactional, moving through direct mail, some of the commercial spaces, through labels, through packaging, and then really picking up quite quickly now in some sectors of industrial print.
Yeah, so it's seen it's and location-wise, you're out. The business is in the Cambridge area, so it started back in the day with some of the sort of intelligence coming out of the university, I believe. Yeah, is that right?
Exactly. Yeah.
Yeah. So over the years, developing new software in different areas is for printing obviously has its challenges. So what are some of the issues that you're seeing right now or within the past sort of 12 to 24 months for these new markets?
It's not just 12 to 24 months. Really, the last 10 years have been very much hearing the same problems from everyone we start working with. They come to us and say, we can't drive our press fast enough. We can't do the ripping and color management, etc., fast enough, or we've got a press running and we can't achieve the quality that we need so that buyers will actually pay for the prints. It's always one of those two. The only thing more important than speed is quality, and the only thing more important than quality is speed. And when we fix one of those for our customers, they immediately turn around and say, now we need you to help with this one. In fact, let me give you some examples of what we're seeing in terms of quality. If I share this, that should be good. Yep. So in quality issues on inkjet, we tend to see very small scale things and larger scale things. So starting with the small scale, on absorbent wettable substrates, we tend to see this kind of streaking effect that you can see in the top left. And on less absorbent, less wettable substrates, we tend to see this kind of mottling that we dubbed orange peel. I guess with the right colors, it looks a bit like orange peel. And, almost everyone who comes to us with either heavy coverage aqueous or UV inks, it's one of these two. And down in the bottom left, I've thrown in an image to show what we can do to help people get over that. This is the result of using our screen protect technology. And then on a larger scale, if I can drive this properly, on a larger scale, we tend to see banding. And this happens both on scanning multi-pass printers and on single pass. And you can clearly see in the top here, you can clearly see the width of one head on a single pass printer, because that's where the dark bands are at the ends of the head. And again, I've thrown in some examples here of what we can do to help people with our print technology. So those are the common quality issues that we're working with.
Yeah, Martin, thanks for that. And what we're saying there is that we can address some of the low frequency and high frequency quality issues. I want to bring it back to speed, because what we're seeing in the market, Marcus, is that resolutions, widths and colours are growing, and obviously with that and the requirement for, in some applications, for variable data, seen a massive rise in speed requirement and data rate requirement. Martin.
Yeah, I'm going to share this one again. And so yes, what we're seeing is increases in number of colorants, increases in resolution, increases in substrate width, substrate speed. And you can see from this diagram that those all have a massive increase in the data rate requirements.
Yeah, I think we can return back to this a bit later.
So from what you're saying is that the challenges tend to be uniform across a lot of different sectors, do they? So it's speed or quality, they're virtually identical in terms of the level of importance, and it tends to be that the issues are people want the right resolution and the right speed in different industries. And I guess that the technical challenges increase when you're printing, particularly digital print, in new applications with different surfaces and different challenges. So that's where software, from particularly it looks like the print flat innovation that you have, really provides a great solution. Is that right?
So yeah, at Global Graphics, we've got a great advantage of our building blocks and SDKs. Can be deployed in multiple ways for multiple different sectors. So, for example, in the textile industry, you may not need variable data, so you could scale back your need for power and performance. Whereas in the label and packaging sector, you need lots of variable data, so you scale it up and grow it. But essentially, they're the same building blocks, which gives us great, access to other sectors, so you can dress it up how you need to.
Right. And just back to basics for a moment, so pardon my ignorance, but what software do you tend to find in a digital press? Yes, Ian.
Yeah, I'll take this one. So your digital front-end software will usually have two elements to it. So there'll be the user interface, where you will choose what jobs you want to print and what settings, the colors, imposition, and so on. You decide how you want it all to look, and you press a button, and then something happens behind the scenes to get that from your PDF or your input image file all the way to your printer that you want to drive at the highest line speed that it can muster and get the highest quality that that it's capable of. So there's two elements. I won't delve more into the user interface because I think we already are kind of all familiar with it. But I think it is worth now going into detail about the stuff beneath the surface, a bit like this iceberg. So the UI at the front, you can see that, but what's underneath? Wow, here we go. So this is what goes into a digital front end. So sometimes it's good to do things with an example. So I'm at home at the moment, not in Iceland, but I've got some trading cards here. And they're a good example to go through this. So no one in their right mind would try to print on an individual card. But what they could do is print on sheets. So you might have 100 cards on a sheet, and there's your imposition right there in your pre-processing. Now, if you're developing your own game, then maybe initially you might do a prototype and do that in monochrome. But maybe later you would take your original RGB and try and convert that into CMYK, because obviously RGB is what you're looking at on the screen, and the press, though, works with ink. So you've got your imposition, you'll choose your color settings, and then you hit go. And at that point, we're going to hand over to Martin to talk about ripping.
Yeah, because if you've got a PDF coming into the DFE, it comes out of the pre-processing stage still as a PDF in most workflows. But the inkjet heads don't understand text. They don't understand this is a red uppercase A in Times Roman. They understand a grid of dots that says, I need you to fire, I need you to jet the ink here, I need you to not jet the ink here. And that's exactly what a RIP does. It converts from all of the graphics in the PDF file, all the different color spaces, text, smooth shades, fills, strokes, images, all of those things into essentially a grid of pixels that say, well, this area needs to be 20% gray, this area needs to be so much cyan, so much magenta, for all of the area of the sheet. Now, obviously, that includes interpreting the PDF file, which basically means just reading it in and understanding it, doing color management, and then rendering, which is writing out into that grid of pixels. Now, it sounds very simple, but as far as I'm concerned, that's where the magic happens.
Well, I beg to differ, actually, Martin, because I think where the magic happens is in the screening, because it is actually an optical illusion what goes on there. So for each of your separations, you've got your different levels of gray. If it was an 8-bit output, then you'd have 256 levels, 0 up to 255. Those have to be turned into something that an inkjet printer can handle. So we need to turn it into dots, different size dots. And that's what your screening does. So depending on, you might only have a 1-drop screen, which would be some ink or no ink. And due to some magic that I don't fully understand, I just like to call it magic, you can turn, to the naked eye, it can look pretty much similar to the original grayscale. And especially if you've got high quality screens, or you go up to say 3-drop and so on. So this is also where the print flat takes place within the screening. You can calibrate for different linearizations, as well as each press has a different kind of personality. Some nozzles might point slightly the wrong way. Some might jet just a little bit less ink. And that's where, with print flat calibration, you would print something out, scan it in, and then that will feed back into the screening and compensate. So that's how you then get the very even output. So I think it's screening where the magic happens.
But I think Ian and Martin, I think you're both right, because the magic of global graphics is how you can bring all these components together in different integration options, and you can have them separate, you can have them in line. So for example, the workflow can do the ripping and the pre-PDF work, but provide print-ready PDFs, and you could have the screening actually on board your print engine, taking control of the dots, which is a great environment to be in, because you know exactly what it's going to be printing, and you know exactly how it's going to be optimized for your substrate, for your inks and drying techniques. And as we see, more and more need for higher data rates, so wider resolutions, and in the textile market, there's more seasons and lower volumes, more versioning, more online retail with boxes and Amazon, especially in the times we are today. It's just driving data rates higher and higher and higher.
Can I ask a question there for you guys? And obviously, it's sounding particularly with industrial markets, it's a high level of customization, is it? often we buy when we buy consumer software, it's off the shelf. This is, to what extent is this off the shelf? To what extent is it highly customized?
Honestly, I think you can customize anything with digital. That's one of, when you depart from the traditional and you go to digital, you can do short print runs. And if you can drive your press on the fly, if you've got the software to do that, rather than generate it all in advance, then if you need to only do 100 or even a one-of-a-kind dress with a particular color that no one else has got, that's possible with digital. I think Martin was going to say something.
Yeah, I was just going to say, we've got the foundation technologies that will do pretty much anything that any of the press vendors coming to us need. So that's all production proven. It's been shipping and running and being improved for a couple of decades in digital print. And that makes it very trustworthy and fast to market. But obviously for every different press, working at different resolutions, different inks, different substrates, different drop sizes, then there's a certain amount of customization required to work with the vendor to make sure that we can achieve the highest quality on that device. And for different markets, you also need different user interfaces, so we can work with our OEM partners to understand what they need to be able to control, what terminology they need to use on that user interface for that particular market sector.
Yeah, very good. And how do you unlock the potential of new markets with software on that note then? So is that part of the process that you work with OEM partners very much to solve their specific problems?
Yes, very much. And what makes the potential in a new market for inkjet is typically not down to the software. It's down to the physical characteristics of what you're printing on and what you're printing with and how you need to process it. To take an example, the ceramics market took off on inkjet because people realized that with a non-contact printing technology, they could make the tiles half as thick, which reduced the price of firing them, reduced the price of transporting them, and a whole bunch of other things. Not even talking about short run lengths, which came in later because it wasn't the driver for the transition. We're seeing the same in textile at the moment, where there are obvious benefits in power usage, water usage, pollution reduction, etc. So the fundamental benefit of inkjet in each different market sector is down to the inkjet. Once you've identified that benefit, though, you have to build a press that can produce a high enough volume to make a profit at a high enough quality that the buyers will pay for it. And that's where we come in. Because the vendors tend to identify the opportunities that they would like to get in, and then they come to us and ask for help.
Brilliant. Jeremy, have you got anything to add there?
No, I think Martin's did a very good job of explaining that. I think it's...
Yeah. Okay. So quality and speed go hand in hand, and that's across all the sectors. And is industrial, with the industrial sector, is that more of an issue given the kind of variety of different markets that you're expected to work within? So that's Martin.
Yeah. There's no point in going really, really fast and producing something people won't buy. There's no point in producing something perfect quality that you can't make profitably. So we have to work with vendors to make sure that they can achieve both the speed and the quality in whatever market they're working in.
Martin, could you bring up the slide again? The data?
Yeah, sure.
So we've already seen how some quality issues can be addressed with print flat and so on. But another way to just raise quality in general, we've covered it a little bit before, is that you would raise the DPI. Generally, that will raise your quality. You can raise the screening that you're using. Then we've talked about speed. If you want to drive your press faster or at least get more output from it, one option is to double the width of the press. Like we were printing cards earlier, I'd now get 200 cards instead of 100 in the same time. So this diagram here is showing our starting baseline press is a 600 DPI, 100 meters a minute, 20 inches wide with a 3-drop screen. And that takes 120 megabytes a second for each colorant, which your hard drive and your computer could handle that, no worries. But as soon as you move to 1200 DPI, you're now up to 480 megabytes a second, which is, if you bought a top-end hard drive, a solid-state one, it could manage that. So you're fine. You could still run your whole business off a hard drive, as long as you had one hard drive per colorant. But then what if you want to run your press faster? So you've been working really hard on this press so that it can jet ink super fast and it can send the substrate under very fast. But if you can't drive the amount of data to it that it needs, you can't run it that fast. So across there, we've got 1.4 gigabytes now to do it at 300 meters a minute. But like I said before, if you want to go wider, well, or you might be doing floor coverings or wall coverings, or just want to print more cards, for example, then again, you've now doubled the data rate to 2.8 gigabytes. And the technology at the moment in print heads is going up to even 7 drops, 6 picoliters, 12 picoliters, and so on. So then you're looking at 5.7 gigabytes for each colorant that you need to get to your press to drive it at that speed.
And that's per colorant. So obviously, if you're on monochrome press, then that is the total, but most people are on CMYK or more. So multiply it up by 4 to get to CMYK data rates. Then you go into other spaces that require more than just CMYK. So in labels and packaging, you might be adding extended gamut colorants, orange, green, violet, or white and/or varnish. In the wide format, you might be adding light cyan, light magenta, white as well, maybe a metallic too. And pretty much every industrial print space has its own different collection of inks, but many of those go beyond 4 colorants as well. So, you multiply this up for a press with, say, 8 inks, and you're well over 40 gigabytes per second.
So the old workflow, the traditional workflow of you get your plates made and then you run your job, some people are still following that same policy with digital, where they would almost lump the ripping and the half toning into the pre-press, and then they'd have loads of files on disk, which they would then use to drive their press. Well, that just isn't going to work anymore. You need a new engine in your software. The old engine is the disk-based one. That's a bottleneck. What you need actually is to be able to drive the data and not touch the disk at all. You read the PDF, and then we've already seen the DFE diagram. You want to send that all the way through without requiring the disk, all in memory, and drive the print head directly. And that's how you can hit these data rates that people require.
This is sort of, like I say, a non-technical person asking a question. Is the data rates with industrial higher than traditional paper printing? Or are they similar, but the challenges are just different?
A bit of both.
Yeah.
Industrial, as I said, tends to use its own ink sets, and it's different in every subsector. Most of the time, the industrial spaces are more similar to UV ink sets on paper and labels. So they tend to be up to around maybe 100 meters per minute, whereas aqueous inks on paper stock are going up to 300 meters per minute. That obviously makes a big difference. But having said that, we're also seeing shorter and shorter runs, more and more versioning, more and more variability, more and more print on demand to avoid warehousing costs, all of those things happening in the industrial space. And that's really why would you think about inkjet in some sectors if you weren't thinking about those things? And the shorter the run, the more every instance of something is different to every other instance, then the higher the speed of the ripping and everything else inside the DFE you need. If your job is going to be sitting on press for 2 hours and you rip it once and you leave it on press, and you've got 2 hours to prep for the next job. But if that job is going to be on the press and off again in 1 hour, 30 minutes, 20 minutes, And I've spoken to people who are running over 20,000 jobs per day on one or two presses. So very short time on press. And for those, you really need the very high data rates, regardless of what segment you're working in.
I think also, Martin, if you look at load balancing, where you've got a production setting, across multiple print engines, and then, one has to be taken out of service for whatever reason. If you've got a static job or static workflow, then it's very challenging to get the right amount of data to the other engines in the right way, in the right sequence to continue the production. Whereas, some of these techniques where we're sharing memory and we're ripping and screening on the fly really allows for true load balancing type situations in a production industrial. What is a true industrial production?
There's other benefits we haven't even covered yet. Like, okay, you don't need to go onto the disk anymore. But also, if you're running a press shop and someone comes along with some PDFs, at short notice, I don't know, somebody cancelled, you've got some time on your press, you could literally just load up that PDF, press go, and it could be running on your press. Whereas most other settings, that couldn't happen because you'd have to do the pre-press and so on, rip it to disk, which could take a long time, read it off the disk. So the idea that you'd be able to be more responsive to what's going on in your business. I mean, COVID is the elephant in the room, but if you can't have, if your factory can't have many people in it, then you could plan for that and decide, right, I'm going to set up all these jobs to run during the day and not have many people there around the press. You just hit go, off it goes. That's it. It'll just do it on the fly for you, then come in later and check out the results.
Absolutely. And Marcus, what we're looking at there is how do we, to create that environment, how do we take out the bottlenecks? And we've got to create a deterministic environment, and the deterministic environment, with PDF, it's very, very challenging. So we have some great technology which normalizes PDFs and creates better quality, higher quality PDFs, so more predictable in terms of being deterministic data. And we're finding if we run those through, a pre-production environment, we know if those PDFs can run at the speeds that we need for the latest devices today, and which are getting faster. Some of them are 150, 300, even more meters a minute.
Yeah, interesting. How does this new graphics pipeline fit with Harlequin, which I know is obviously one of your flagship brands?
Right. I haven't actually mentioned the product names, have I? So the direct product range has Harlequin Direct. So that is ripped by Harlequin and then uses the Screen Pro component, which includes the print flat, to be able to get the speed that you need and the quality you want. But I think I'll hand over to Martin to talk more about the Harlequin in Harlequin Direct.
I talked about the RIP in the DFE, and essentially what we've done here is to look at the components we've been selling to a number of different press vendors over the years, and identified exactly what Jeremy was just saying about printing companies, but now thinking about the press companies themselves. We've identified their bottlenecks and said, you know what, we've got all the components you're using. We recognize that the system engineering to glue those together so that you can feed data through at very high speed is a challenging problem. So we've combined the components together in more of a complete workflow that we can provide to press vendors. And we can say, look, here's a very large proportion of the solution for you. We know it works. It's tested and shown to work in production. It'll give you a better solution than many of our vendors could achieve on their own because they don't have their own software development teams. Oh, and by the way, it'll get you to market faster. And then at the end of the day, it'll provide a better product for the printing companies, the converters, the manufacturers in the industrial print space.
The risk of being a bit too technical, stop me if it's too technical, but the Harlequin RIP, rather than write out to disk, we talked about this before, communicates with the Screen Pro component over shared memory. So you're not touching disk, memory is a lot faster than disk. And The RIPs work in parallel as well. So if you've got, say, a 32-core machine or something, I'm really passionate about this high-performance computing. That's my background.
You can tell.
Yeah. So you could have, say, 8 RIPs running in parallel, each one dealing with a page. And when it's finished, it goes into the shared memory. You can have 10, 12, 16 screening threads that each one, once the page arrives for them, then they go to work on the screening, applying the print flat if you're using that. And then when those are finished, they will get sent to the print head in the right order. You need a scheduler, otherwise your pages will come out in the wrong order. But it's about hooking them all together in such a way that you don't need to touch the disk. Because all of the components of the direct range are made by Global Graphics, we've got access to the source code. We've got access to the experts who worked on them. So we've been able to create a really finely tuned, optimized pipeline.
So it's adding that additional performance without affecting the core performance of the machine. So it's kind of having I get that. That's quite clever. Quite a clever problem to solve there, isn't there? In terms of being able to work at optimal levels.
Yeah, there are a number of processors anybody could choose. I mean, if you want really top end, that's going to be expensive. So maybe you might want to go mid-range. But improvements are happening all the time with processors. So one of the things we've developed to try and help people evaluate direct is something called direct benchmark. So the idea there is that if you're already running your press with some computer system and you're thinking of developing your next one, then you could try out the Harlequin Direct on there and see what kind of data rates you could achieve. Or you could come to us saying, I want to go at 150 meters a minute at this DPI. What machine do you recommend to use? And we can use direct benchmark to then find out what data rates can be hit for typical jobs. So that really helps people who are considering maybe they're going to make their first digital press. And they want a rough idea, how much is it going to cost, what computer parts do I need, and so on. If they come to us early on, then they can plan that bit out and plan out the software rather than make this brilliant press and have no way to drive it. You want to try and involve Global Graphics early on, or somebody else, but come to us first. And other vendors are available, but come to us because we love solving problems for people. At least I do, anyway.
Is that a common issue that, as an industry, we're a little bit kind of obsessed with the actual large engineering performance of machines?
Absolutely. I've lost track of the number of people who called us in because they spent 10, 15 million pounds, euros, dollars, your choice. And they build a press and they know it can print because if you put a BMP file in this directory and type a set of runes at the command prompt, you can get a print out of the back end. And they're getting ready to ramp up to sell it and suddenly realize, actually, that's not sellable. Well, it is in some very, very niche specialist markets, but in the volume markets, that's not sellable. You need that DFE on the front with a human usable user interface and I think, with the right technology.
I think, Martin, they forget the power of software as well, because
absolutely, yes.
If we look at some of the hardware issues that can actually be fixed with software. And look at the low frequency and the high frequency issues that you see in the print.
Yeah, if you look at the banding that I was showing earlier, the reaction of most of the press vendors is, "Oh, we'll tweak the voltages on the heads," and
they forget about the velocity issue. Then,
yes, and it's slow. It's not very effective because there aren't enough control points on each head. It's expensive because it needs experts to do it. It doesn't allow for different corrections at different press speeds, which we certainly see. And then we walk in and say, well, you can do it with PrintFlat, you can do it in software. And by the way, that's completely automatable, or nearly so.
Right. So if you've got an automated factory, in times like these, it's all automated, no human person checking the output quality and feeding back. I mean, if you're all digital, you can build in computer vision systems and so on. Live checking of the output, feed that back to your print flat, and dynamically adjust. Maybe it was cold this morning in the factory, but suddenly it's got hot, and how that's affecting the level of ink that's coming out. I'm no expert on the ink part yet. I'm trying to learn all these things. I'm more a software guy, but all those factors, you adapt to it.
It's more than that as well, because you've got a return on investment there and a bill of materials. And Martin always, when he makes his presentations, he always refers to the bill of materials and reducing cost.
Yeah.
If you've got optimum, software that's really powerful, that's scalable, and you're not writing to disk, you don't need the big hard disk. You don't need the big computer. You can reduce the cost of your hardware and computers in a given system, because you don't need the storage.
People ask me why I keep yelling about speed on ripping and screening, and it's really in 3 steps. If your speed is really low, then you'll have some jobs that can't keep up with the press, and you'll have to run the press slower or even stop it in some cases. Once you pass that stage, it's down to exactly what Jeremy was just saying. You can reduce the bill of materials. You don't need as much hardware with really fast software. And then the third step is, oh my goodness, we're selling this, let's say, narrow web 600 dpi press with CMYK. And my marketing department has told me that our next generation press has to be 1200 by 1200. It has to be twice as wide, run twice as fast, and have 6 inks instead of only 4. And suddenly I need a 20-fold increase in the data rate. That's a huge step. And that's exactly the kind of thing we help our customers with.
Yeah, and it sounds like it's solving the right problems at the very beginning. Yeah, and I've heard this too from various markets, that often if you don't get that right first, you spend a lot of time solving problems you shouldn't have to later on, and it gets expensive and so on and so forth. Just finally, what are the fastest presses that Harlequin drives? Because they're in different I know we're obsessed with speed in our industry, but what are the fastest ones? Yeah.
Well, the fastest ones at the moment are in aqueous inkjet printing on corrugated. Yeah. Aqueous presses tend to be quite a lot faster because you can dry faster than you can cure UV inks. But those are 300 meters a minute, multiple meters wide, and running with, I think, 6 inks, and they take something around 45 gigabytes of raster data per second. That's huge.
Yeah, mega.
Faster than my family consume Netflix. So that is a
and in terms of the amount of data, it's kind of gigabytes and stuff like that, which is just hard to compute in terms of its scale.
Of reliability. The number of disk drives you would need, even if you had enough, if one of them fails, it's going to take down your press. So you'll be missing a color or something like that. So doing it on the fly, you can adapt to it as well. So that's just another factor we didn't even mention. Right. The reliability.
So if I'm thinking of, I'm an OEM manufacturer that has perhaps presses that are analog and so on, looking to develop a new machine, then speaking to you would be a good thing to do at the beginning.
Oh, absolutely, yes.
And also, I guess, as well as that, if you've got a machine out in the market that you're having problems with, you'd be good people to talk to about that, and you can help problem solve, even if you haven't been involved at the beginning. Yeah,
we've certainly had a few people in that position. They've got shipping presses, they've got customer complaints, and they know they need to fix something. They need to do it quickly to keep their reputation in one piece. They come to us and we'll be able to help.
We see ourselves as the go-to people for ripping and screening challenges.
We've seen that software is a really important element of your press. Not everyone can have a dedicated software team at their company. Big OEMs, they can invest in software developers to try and match the kind of speeds we've talked about. But if you're just going into digital, you're probably not going to have much experience with software. That's where we can help. That's really where our value is. We're the experts on the software, 30 years. That's what Martin's got, all this experience. We love solving problems. So why not give us a try? and maybe we can create a successful new press together. So
Yeah.
Superb. Well, listen, thanks so much, guys. That's a brilliant way to end this session. It's been eye-opening for me, clearly critical. You're there to help. Great people, I'm sure, would help a lot of people in different industries really make their vision come to life. So thanks so much.
thank you.
I look forward to seeing you again soon.